Hey guys, check this out. This is the X100 Infinity Wing by 3DAeroventures. This thing looks so cool. He's improved it. This is the version 2, so it's got a little bit different wing design for a little bit better flying characteristics, and it has landing gear on the version 2. So let's take it back to the workbench and we'll show you guys how to put it together. Okay, so before I show you guys how to assemble the X100, I do want to cover some things on the printing process that's slightly different than other planes I've done on my channel. So when you purchase the STL files, you will get STL files and G-code files. G-code files are meant to throw right into your printer with a roll of PLA and hit print, and they'll print the parts out. Now, some printers will not work with all the G-code files because G-code files are usually specific to a certain printer or a certain kind of printer like bodin tube or direct drive printer. Now, I decided to slice all my own parts for this plane in Cura so that way I could show you guys any tips and tricks I found along the way. And there's two main things that you guys need to make sure you guys have set up correctly when you're printing any of these parts for the X100. The first thing is that for all the parts, they are designed with the infill inside of the wing and inside of the fuselage parts. It comes out with a really nice quality print, and they're very strong parts. So in Cura, under the infill tab, you scroll down and there's a connect infill lines. You need to make sure that's not selected. And if you have that selected, it will add a lot of weight to your airplane. So I actually printed out one with the infill line connected selected and the one without it selected, how it should be. And we can put it on the scale and see that, you know, that's 76 grams, which is what it should be, and the one with connected infill lines is 91 grams, so it's significantly different. So make sure that you don't have that selected in Cura. Okay, so the second thing I want to cover with you guys is sub-extrusion. Now this is a severe case, and there's a different cause from this than the traditional cause. Normally, you'd see the sub-extrusion and I would say, oh, your retraction settings are not set up right or your prime settings aren't correctly. But if you watch this print very slowly on your printer, it'll start going around, it'll cover all the infill, it'll print everything, and it'll start right on the Z-seam and start printing this outside wall without having any prime. Now how you fix this in Cura is you need to make sure that you have it selected to have retraction at layer change. Now if you select that, once it goes to the next layer, it will be forced to make a retraction and then therefore a prime right there at that Z-seam, which will then fix the sub-extrusion. Then you'll just go right through your normal settings. If you're getting slight amount of sub-extrusion, increase your prime, decrease your retraction settings, and you'll get the settings right. Also, if that doesn't fix it, then you can select retract before printing outer wall. That will also help make sure there's a retraction before it prints this outer wall. So when I was working on getting my priming and my retraction set up, I did use the fuselage 4 part. It's a nice small circular piece that I can have on the printer. That doesn't take very long to print. It only takes like 30 minutes to print that much of it. From 3DAeroventures, they do recommend to print at 0.3 millimeter line width. Now, even if you have a stock 0.4 millimeter nozzle in your printer, you can actually print slightly thin walls with a 0.3 millimeter setting on your Cura settings. Okay, so I printed this plane out in PLA. I wanted to test out 3DAeroventures' new design for the X100 in regular PLA, but I would recommend printing this in lightweight PLA because this is a really good plane to print in lightweight PLA because of the design of the wing and because it has some grid sections that go inside of the fuselage parts that makes it really strong. So I have a part here. This part is printed out of regular PLA and this part is printed out of lightweight PLA, and you can see the difference between the weight. The PLA is much heavier than the lightweight PLA. So I definitely would recommend using ColorFab lightweight PLA for this build. If you can, get it from 3DAeroventures, and it's much cheaper for the shipping if you get it from 3DAeroventures. So check out their website to get some new lightweight PLA. Okay, last thing I want to cover is this printer. This is a Sapphire Pro by Twotrees. This printer worked amazing for printing thin wall. It is a bodin style printer, but it has this awesome dual drive extruder, which makes a really consistent retraction and priming system that's actually more accurate than my direct drive printer. Also, it has a bed that moves up and down versus having the Z-axis move on a tower, which makes it way more stable for printing very thin parts, like printing aileron parts and everything, very tall parts. It makes it very stable. It does take a little bit of work to assemble. Out of the box, you have to obviously assemble the whole frame structure, which isn't too bad, but then you have to also hook up all the wiring harness and run it through all the looms and set up all the belts for the drive system. So it does take a little bit of work to set up, but once you do have it set up and running, this printer works awesome. This is my new favorite printer for printing thin wall in my office here. I definitely recommend using one of these Sapphire Pro printers if you guys can get a hold of one. I'll throw a link in the description to purchase one. And let's head over to the workbench, and then I'll show you guys how to put this whole X100 Infinity Wing together. Alright, the first thing we're going to work on is fuselage 2. We're going to go ahead and insert the rudder servo bracket in place, and then we're going to use these threaded inserts and use a soldering iron to insert them into this fuselage 2 part. This is one of my favorite parts about 3DAeroventures design is these use of this threaded insert. It works really well for taking parts on and off like wings and landing gear. Alright, and then we're going to go ahead and insert these fuselage tray in place. This is one of the reasons why this plane would be a really good plane to print with lightweight PLA. It has this tray that you could print out of PLA and then print the rest of it out of lightweight PLA. And then it would keep the fuselage nice and strong. So I did mention in the beginning of the video that version 2 comes with landing gear. It actually is an additional cost to have the fuselage with the landing gear. It is different fuselage parts, comes with a vertical stabilizer with a rudder and that servo mounting bracket and everything. So I would recommend purchasing the upgrade for the fuselage with the landing gear because it makes it much easier for that critical maiden flight where you're going to take off and you don't have all your trims and everything set up. And you don't want to have somebody try to chuck glide it. It makes it a lot easier to take off and land with the landing gear. So I would recommend getting the upgraded fuselage with the landing gear. Then we go ahead and use a hot knife to clean out fuselage part 1 and 2 where the canopy goes. If you don't have a hot knife, you can use like a Dremel tool or a soldering iron can also kind of melt through that, and then use a cold knife and some sandpaper to clean up the edges. Okay, now we're going to grab a 24-inch extension and a 6-inch servo extension, and we're going to connect them together. I use a servo connector to keep them from pulling apart inside the fuselage. Or you can just use a piece of tape, works good too. This makes it a lot easier once you start to hook up the servos if you can put the servo extensions in now. If you don't put them in now, then you can use like a string with a weight or something on the end of it to try to feed that through the fuselage and that vertical stabilizer to get the servo extensions in place. I'll be using 12-gram Metal Gear Emax servos for this build. I'm going to use this control horn, drill it out, and set a adjustment collar in place, and then we'll put a little dab of glue on there to keep that nut in place, and then we'll cut the control horn down to size. Make sure you hook up to a receiver, bind that to your transmitter to center the servo and make sure it's operational, and then we'll put the control horn in the correct orientation and put the set screw on the servo. To set up the rudder for this build, you'll need a couple of different wires. You'll need a 2mm steel wire, a 1.2mm carbon fiber rod, and a 1.2mm steel wire for the push rod. And you also need these 3mm dowels. To bend the steel wire to shape, 3DAeroventures provides a PDF file that you can print 100% scale to lay the steel wire onto the PDF file to get the right shape. I'm just going to go ahead and bend it, basically using the tail wheel and the rudder as like a reference to what size to make everything. And then we're going to add these collars onto both sides of the wheel, and then we're going to use a little bit of Loctite to set on the set screws, and we'll cut that steel wire to length. We'll go ahead and insert the tail wheel in place on the bottom part of the rudder and glue that to the top part of the rudder. Now go ahead and take that 1.2mm steel wire, put a Z-bend on one end, slide that into the fuselage, and then because we already have the rudder servo set up with the adjustment collar, we'll just slide that right in the adjustment collar and that'll be set up. And then we'll just go ahead and set the rudder onto that Z-bend that we just made on that steel wire, take our 1.2mm carbon fiber rod, slide that down into the vertical stabilizer, and make sure it moves nice and freely. We'll put a little dab of glue in that last part of the fuselage to set that carbon fiber rod in place. We'll bind the receiver to the transmitter again, center the servo, put a little bit of Loctite on that set screw, and make sure the rudder is aligned with the vertical stabilizer. We'll use a pair of pliers to hold that adjustment collar to tighten down that adjustment collar. And then we'll cut that 1.2mm steel wire to length. For the wheel pants, he uses 1mm carbon fiber rods as like an alignment tool to align the front half to the rear half of the wheel pants. So we'll just go ahead and cut those to length, add a little bit of glue, and glue the two halves together. We'll insert the wheel in place. For all the exact lengths for screws and nuts and stuff that you'll need for this build, definitely use the PDF file that 3DAeroventures provides when you purchase the STL files. I'll be using a Leopard motor 3536 for this build. Make sure to print out the correct motor mount. I printed this out at ABS and I printed it out the one that's made for the Leopard motor, but there also is a motor that's made for like the E-Flight motor also. Now we're going to set these 3mm nuts into the fuselage one. I use a small 3mm screw to kind of run these nuts down into the fuselage. And we'll add a little bit of glue to those to hold in place. We'll set the motor mount onto the Leopard motor, and then we'll make sure that the motor mount that's printed out is in the right orientation on fuselage 1. So the arrow should be pointed up. That will create a right downward thrust, which is what you want for RC plane. I use a 11x7 APC prop for this build. So now we'll go ahead and grab the canopy. We're going to use these 3mm dowel pins to align the front half to the rear half of the canopy. We'll glue that in place. Use a hot knife again to cut out the support parts in the canopy. And then we'll use these magnets to hold the canopy to the fuselage. We'll just set those in place with a little bit of glue. To make sure you have the right orientation for the magnets, just go ahead and put the magnets onto the magnets you glued into the canopy, and I just use a Sharpie and then put the shiny side up once I go ahead and glue them into the fuselage, and that makes sure you don't have the orientation opposite once you glue the magnets together. So this rear section of the wing, there should be supports printed right here. I didn't actually print supports for mine, but I just clean up the PLA there. If you do have supports printed there, just clean up the supports there. We'll add these threaded inserts into place for this wing section, and then to glue them together, we'll use 6mm carbon fiber tubes. We'll slide them into place, and we'll use them as an alignment tool to align the two halves together. So we'll just add glue. Make sure you don't glue the carbon fiber tubes in place. Once we have those two parts glued together, we'll pull out the tubes just to make sure they don't glue them in place. And then once that dries, we'll go ahead and slide the servo extensions into this last part of the wing here, and we'll glue that to the top of the vertical stabilizer. Alright, so the next thing we're going to do is start working on the wing. So I'm going to work on the rear section first, and then we'll do the front section. It's pretty easy. With the rear section, we have all the ailerons and the servos and stuff to add. So before I start gluing these together, the very first thing I'm going to do is make sure that the carbon fiber rod that you're going to use goes through all these plastic parts for the hinge points for the ailerons. So at first they didn't. So what I did was I just used a Dremel tool with a 1mm steel wire and put that on the end of the Dremel tool, and then I just run that through the ailerons and through all the hinge points to make sure that this steel wire will go through there okay. And then once I did that, then the carbon fiber rod will go through the ailerons very easily. So make sure you do that first, because once you get this thing all together, it's going to be a lot harder to do something like that. Alright, so let's go ahead and we'll start working on one section, and then we'll just do the same thing on the other wing. To glue all the wing sections together, it's pretty basic. There's all these alignment tools built into the print, so it makes it really easy to assemble it. I am using Zap-A-Gap medium CA glue to glue all the parts together. Now at this point, we should be gluing that last part of the wing together, and there's a hole here in the last part of the wing tip. You should be able to put the ailerons in place and slide that carbon fiber rod in place. But what I'm going to do is I'm actually going to glue together these ailerons first. So I'll use the 1.0mm wire to align the aileron pieces, glue them together, and then I'll go ahead and set that in place on the wing and slide that 1.2mm carbon fiber rod in place as the hinge point. Before you glue the last part on, make sure that the aileron moves very easily. You just want this to move very freely and no strain on the servo. For the wingtips, they are printed with a support just like this, so make sure that you clean off the support parts before you glue them together. Before we glue on the middle wingtips, we'll make sure we put the last set of heat inserts into the middle wing sections, and then we'll glue those in place. So we want to use the same setup for the ailerons, where we're going to put the Emax servos in place, and we're going to bind that to our bind our receiver to our transmitter and center the servo, make sure it's operational, and then we'll set the control horn at the right orientation, put the set screw into the servo, and then we can also use a little bit of trim on the servo to center the servo if we want to make that control horn right at 90 degrees to the wing. We'll feed the servo wire into the wing and use a little pair of tweezers to pull that servo wire through, hook that to our receiver again so that we can make sure that the servo is centered. We'll use a Z-bend on one end of the wire. We'll put a piece of tape on the aileron to align it with the trailing edge of the wing. We'll use a Sharpie to mark where our other Z-bend will be at. We'll cut that to length and we'll insert that into the aileron. We'll twist that servo and get that lined up and put the screws to hold the aileron bracket in place. You can use adjustment collar for the servo on here also. Just put it on the servo and then run the wire through there. I choose not to do that, especially with this airplane. It's only a 4-channel airplane, so there's a separate channel for each servo, so I can just independently trim each servo to get them lined up how I want them. And then we just repeat the whole process for the other half of the wing and glue everything together. So the front section of the wing is much easier, just have to glue all the sections together. To attach the wings to the fuselage, we're going to use 4 6mm carbon fiber tubes. There's one at 200mm which goes in the back here, and then the other ones are all 300mm at length. And then we'll go ahead and insert all those in place, and we'll set the wings onto the carbon fiber tubes, and then we'll use 12 3mm 15mm long screws to attach the wings together and to the fuselage. When you're attaching the back wing, make sure you do connect the servo for the aileron. Do use a servo clip to hold those together to make sure that you don't pull them apart when you're pulling on the servos inside the fuselage. Do make sure that you attach the screws on this rear section first before you put the screws in place for the wingtips, because then you do have kind of the leverage to get the screws in place on the wingtips after you get these wings attached. Okay, last thing we gotta do to get this airplane ready to fly is just finish up electronics. So we'll use a piece of Velcro to hold the receiver in place. We'll add an extension to the ESC, and we'll solder on an XT60 connector for our battery. and we'll use a heat tubing to clean all that up and to hold the wires together. We'll feed the ESC down into the fuselage. I'm going to go ahead and put it below the tray section, and that allows me to have room for the battery. We'll have the XT60 connector sitting here, and we'll go ahead and set the battery in place to set the CG. And then we'll just finish it up with a set of decals. Hey guys, alright, we got the X100 all done. It looks really awesome. We have a 4S 4000 milliamp battery in here. This is a little bit larger battery than the PDF recommends. It wants you to fly like a 3-cell 2200 milliamp. But I did put a little bit larger battery in here to set the CG because the back wing is a little bit heavy. We're about 1800 grams ready to fly weight right now. Alright, so we got the CG set. It's just about where that carbon fiber spar is at. You can kind of see that dark shadow there. That's about where the carbon fiber spar is. So just in front of that, it's about 45 millimeters. So that's why I have that little bit bigger battery in there, because I have the CG set. So it would be like under the weight that the PDF says if I would put like a 3-cell battery in there, but then the CG would be too far back. So I did use a little bit heavier battery for that CG. So we have a little heavier plane, a little bit bigger battery, but the CG's right. So let's see how it flies. Alright, before we take this up and fly, make sure that do all the pre-flight checks, make sure the propeller is okay and the controls are all working operational. I did set up high and low rates just like the PDF said. I flew it in high rates for the maiden flight just to make sure I had full control of it. I didn't have too much time I could add for flight video because the build video was a little longer for this plane, so make sure to check back for my full maiden flight video. And thank you guys so much for watching. We'll see you guys in the next build.